So it gives us an hour to do day 11. Now, again, these tend to get harder and harder as they go further and further into the event. So this could be a pain point. We'll find out. Day 11, Chronal Charge. You watch the elves and their sleigh fade into the distance as they head toward the North Pole. Actually, you're the one fading. The following sensation returns. The low fuel warning light is illuminated on your wrist-mounted device. Tapping it once causes it to project a hologram of the situation, a 300 by 300 grid of fuel cells and their current power levels. Some negative. You're not sure what negative power means in the context of time travel, but it can't be good. Each fuel cell has a coordinate ranging from 1 to 300 in both the X and Y direction. In XY notation, the top left cell is 1, and the top right cell is 301. Okay. So it's like screen coordinates. 1 is up there, and 300 is down there. Power level. Oh, the interface lets you select any 3x3 square fuel cells. To increase your chances of getting to your destination, you decide to choose a 3x3 square with the largest total power. The power level in a given fuel cell can be found through the following process. Find the fuel cell's rack ID, which is the X coordinate plus 10. Okay. Begin with the power level of the rack ID times the Y coordinate. Increase the power level by the value of the grid serial number, your puzzle input. Set the power level to itself multiplied by the rack ID. Keep only the hundredths digit of the power level. So 1, 2, 3, 4, 5 becomes 3. Numbers with no hundredths digits become 0. And then subtract 5 from the power level. All right, so we're taking the hundredths digit and subtracting 5, which means we're going to get a range of -5 to 4. For example, to find the power level of fuel cell 35, rack ID is 3 plus 10 is 13. That's this thing here. We multiply it by 5, which is this here. We get 65. Adding the serial number, which is 8 in this case, produces 73. Multiplying by the rack ID produces 949. So we just reuse this number. Okay. Hundredths digit is 9. 9 minus 5 is 4. So the power level of this fuel cell is 4. Here's some more example power levels. All right. So we could write a little test to make sure we get it right, but it seems very straightforward. Our goal is to find the 3x3 square with the largest total power. All right. What is the XY coordinate of the top left fuel cell of the 3x3 square with the largest total power? XY coordinate? Are they looking for an answer to be a number, comma, number? That's unusual, but not impossible. For grid serial number 18, largest total 3x3 square has a top left corner of this. Okay, I guess that's what they're looking for the answer. All right, let's set up the template. Oh, I just saw this here. Your puzzle input is 5235. So I guess there's no file to get. We just hard code that into our code. Interesting. A couple of different unusual things here. Let's go to 18 mod. Create a day 11. This doesn't seem too bad right now. Create the module, jump to it. 18, 11, build. What did I do? Oh, I did mud. I do that, don't I? There we go. Unsolved. One ire. Thank you for the follow. Welcome. Glad to have you in the Mad Science Lab. Okay, so git diff, add source. And this is day 11. Okay. 1811. So there's no file to read, so there's nothing to parse. Parse gets left empty. There's nothing to put here, right? Because this is all gets calculated on the fly. I guess we could just shove the serial number in here, right? And just make it as part of this thing here. And it can go negative, so let's make it an I-64. And the parse will just be that, right? Self serial is equal to, what was it? 5235. Done. So let's write a little thing that does this, right? And then we can calculate it based on different serial numbers. Well, I got hard coded. That's fine. We can write a little test for it. This is the power level. Self. X. Y. We're going to do everything in I-64s, even though this is all positive numbers for the grid locations. We'll do it in I-64s. So we're going to compute the rack ID, which is the X coordinate plus 10. Okay. Then the power level starts at, right, multiply it by the Y coordinate. So all we're going to do is return this, right? So we're going to say the rack ID times the Y coordinate, adding the serial number. And then multiply all that by the rack ID. Oh, wait. Yeah. Rack ID times the Y coordinate. And then we multiply it by the rack ID again. Okay. That's probably, we could simplify this equation somehow. And then we take the hundreds digit, right? Which is mod, divided by 100, mod 10. And then subtract 5 from that. Right? That's the power level, if I'm interpreting it correctly. So we can just test this one here. Fuel cell this at grid serial number this is power level -5. We can also do this one here for serial number 8. Test power levels. And I can just put them all in one test, right? What is this thing called? AOC 2018-11. Right, I can just do that. Yeah. And then this is going to fail. So now we say expected power level, a power level of at grid coordinate 3.5. The actual value should be 4. That passes. Okay, so we got that one right. So let's do these 3 as well. So let's just, oops. So this is serial number 57, and it's 122.79, and it's -5. This is 0 for the answer, and the last one is also 4 for the answer. 196, 217, 39. This all seems like it'll just work, right? 153 and 101. Let's see if I broke anything. Nope, all those tests pass. Okay, so we're correctly calculating the power level. Now we need to be able to do a 3x3 square. Okay, and add them up. I guess one way to be efficient about it is to, as we walk along, we can subtract 1 and add the next. But we're only dealing with 300 by 300 in part 1. Black Hats, thank you for the follow. Yeah, it's only 300 by 300, so it's not going to be that long. So maybe part 2 will make it a lot more complex. But if I just say, for each coordinate, and it's 1, it starts at 1 and goes to 300. right? And for y in 300, we can get the power level for the grid that's around. Oh, we want to actually subtract. We want to go to 297, right? Because we're going to add 3 by 3. There's no grid that starts here, for example. The grid has to start here. That's what I'm saying. Oh, maybe that should be 298 then, right? So 298, 299, and 300. So now we need a delta x and a delta y. Right, and we're going to add up all the power levels. Let mod power level equals 0. And we're going to try to get the maximum one. So power level plus equals. We could actually just pre-compute all these rather than... All right, well, let's see what happens if I just calculated them each one as we get to them. But it's true, we could just create a 300 by 300 grid of x plus dx and y plus dy, right? And then all we need to do is let mod max power level equals 0. And then after we do this, we say max PL equals max PL max of PL, right? And then we just output that. Oh, we need to save the XY coordinate. If PL is greater than max PL, then found x equals x, found y equals y, and max PL equals PL. And we'll just create those. Let mod found x equals 0 and y equals 0. Right? And there we go. And then we can just output format bang x comma y. How's that? Black Hat says, for some weird reason I followed twice. Well, I appreciate every single follow. Run. 3354. Who knows if that's right? Somebody does. And it went pretty quick, right? Even though we're calculating it every single time. This is the brute force way to do it, right? We could just create a grid of power levels and then just access those here. But this works, you know. In debug mode, we're getting it 15 milliseconds, so I'm not going to complain. Let's commit these changes. Let's first make sure Clippy doesn't have any issues. Git commit -am 2018 day 11 part 1. That went faster than I expected. All right, let's see if part 2 is like super easy like it was for day 10. There it is. Or if it's going to be super hard. Continue to part 2. You discover a dial on the side of the device. It seems to let you select a square of any size, not just 3 by 3. Sizes from 1 by 1 to 300 by 300 are supported. Realizing this, you must find the square of any size with the largest total power. Identify this square by including its size as a third parameter from the top left coordinate. A 9 by 9 square with top left coordinate corner of 3, 5 is 359. Oh, okay, and we do get test output. That's good. We can test our code before we submit it. All right, so this is going to add a little wrinkle to the sweater. I don't know, what wrinkles? So we can grab this as code and genericize it. Right, we can pop this up here. Highest power for size. I 64. And it's going to return a string. So highest coordinate. Right? And we do that. Oh. That. Right? And now for here in part 1, we can just return that. Oh, we actually have to return it here. All right, so this is format bang. Found X, found Y. And that just gets returned here. So we can say self highest chord for size 3. Right, so we're doing 3 by 3s for part 1, which means we're going to do 300 minus size for these guys. And it's going to go size here. Right, and this should still give us an answer of, oh, I forgot to add self. I keep doing that when I refactor. Highest. Yeah, 3354. Okay, so it still works. The refactoring worked. I'm actually going to save this git commit-am refactor part 1. All right. And now all we need to do is loop over all the sizes. Now, for doing a 3 by 3, it took us this. So maybe part 2 is going to take a lot longer if we give it different sizes. We're going to do sizes. Can the sizes be the same? It has to be a square. Okay. All right. So yeah. So this is correct. I was just thinking, oh, maybe we could do rectangular things, but no. We're all about that square. We need to return the power level as well. So maybe we should return a tuple of power level, X, Y, and power level. All right? Found X, found Y, and max PL. And then we can format that here. Sort of. Yep, and we're still 3354. Okay. So now we just say for size in 1 dot dot, I guess 300, right? That's the maximum we could go. We can add up all of them. And we could, we just get the maximum power level and find out what that coordinate is. Let found X. And I have to do it this way. Let mod max PL equals 0. Let XY PL equals self highest chord for size. If PL is greater than max PL, then found X equals X, found Y equals Y, and then max PL equals PL. Yeah, and this might take a little longer. So I'm not going to run it here. I'm going to run it in the terminal so I can halt it if I need to. The for loop runs 0 times. Oh, if the for loop runs 0 times, found Y is not initialized. There. I'll separate this out by a little white space, and then we'll go over here and say cargo run. And see how long it takes. Yeah, so it takes a little while. So we can optimize it by caching all the values. So let's do that while it's running. Grid is going to be I64, 300, 300. Right? Oh, you can't. That's right. You can't do a default with that. And that's where my whole thing breaks down. I can do a vec of I64 though. All right. And then in our parser, after we set the serial, we're going to loop over them all. For x in 1 dot dot equals 300, or y in 1 dot dot equals 300. Oh, we want to do it the other way around because we're going to push. We're going to say push self grid, push row equals vec new, row dot push self self the power level for x and y, and then we'll say self grid push row. Right, so this pre-computes all the power levels. And then in here, what we want to do instead of doing this is just grab it, self grid yx. Right? And that way we're not recomputing them each time. Yeah, this is taking forever. Die. Now what did I fail on? Type vec I64 can't be indexed by, right? Oh, dx plus dy. Oh, sorry, dy dx plus x as you size. There. Hopefully we still get 3. Oh, we don't. I was about to say, hopefully we still get 3354, but it looks like we're off by 1 now. Oh, I know why we're off by 1. We're off by 1 because this thing is 0 based, right? We actually have to subtract 1 here. There we go. It's still taking a long time. For doing each size. So yeah, maybe this is where we need to actually be smart about how we walk, right? If we have a 3x3, and we want to move over from this grid of 3x3 to this grid, we subtract the 4 and add the 4, subtract the 3 and subtract the 4, subtract the 3 and subtract the 3. And that gives us this grid without having to grab all these values. I'm curious about how slow it actually is. Oh, missing. Okay. Let's see how slow it is. Yeah, it's getting slower and slower and slower as the size goes up. So we're going to have implement some sort of a sliding window thing. We can try release mode. Still slows down by a lot, right? It should speed up again once there's fewer and fewer things. Like the 300 by 300 is just the whole thing, right? And for the 100 by 100, there were only 100 things to look at. For the 200 by 200, Oh no, there were 200 things to look at here. There were 100 for the 200 by 200. It's getting there. I'm going to let it run. But really, this should be done with a sliding window, right? So when we move from here to here, we got to subtract these guys and add these guys in. And I think that would speed things up. So let me get an answer, because we're almost there for the answer. Yeah, see how it's getting a little faster now as the grid gets bigger. And it should zip to the end. Zip. All right, let's see if this is the right answer. If this is not the right answer, I'm going to cry. Off stream. Oh, okay, I have to cry off stream now. That's a shame. So it took a minute and 11 seconds. And it still came up with the wrong. How is it wrong, though? How is it wrong? This is saying that the maximum power level was at 232, 289 for grid level 79. And I can actually print those out as well once we find maxes. X, Y, PL, and we can watch it. But that's not going to help us debug. That's just going to be a curiosity thing. Well, let's take a look. Let's keep looking at the code and seeing if there's anything. Oh yeah, on size 8. It came out on size 8, and that was the biggest one of power level 79. And it never found another one that was bigger. Let's actually take a look at all these. Because 3x3, yeah, is at 3354, which is what we got before. I wonder if, does this have information about the highest power level? Yeah, it says for the total power of 29. And we have 28 here. Oh, no. Yeah, that's because this is not. Let's do this and see if it says total power of 29. We're going to do grid serial number 18 and see. Just to see if we come up with the same answer of 3345 power 29. Because if we don't, then we know that that's where the problem is. Matanissa says, shouldn't you do a 300 size -1 when scanning on line 26? I'll take a look in a second. Let me just see this here. For a size 3x3, it does say 29. Okay, so we're getting that right at 3345. So that's right. Okay, let's take a look at line 26. You're saying here? It shouldn't be -1 because we're starting at 1. If size is 1, we're going to be going, oh. Yeah. If size is 1, let's see. There might be a problem here. +1. Yeah. So that you might be right. Because when we start at size 1, we want to go from 1 to 300. And we want to add that in. I think you're right. So let's just throw that on here. All right. Okay. And then I got to change the serial number back. Yeah, it's not surprising that his example has a highest power level in the middle, and then the actual data has a highest power level on the edge to catch you out on edge conditions like that. Let's find out. Okay. Did it change this? 232, 289, 79. Oh, I don't know what I put in there before. And I don't have it anymore. I think that was the same one, though, wasn't it? I remember 79. We can see if there's higher ones, but I don't think they're going to be higher ones because we're adding in too many negative numbers. The bigger the square, the bigger the size, the more this is going to average to 0. Right? Let me just try this again. Just in case this is a different number. Because I honestly don't remember what the previous one was. No. Okay, it's in there. Oh, I didn't click back before. Okay. I must have just clicked go back to the puzzle. Yeah. There's nothing going to be bigger. All right, so it might be that this coordinate's wrong. Is there anything else here that might be wrong? Maybe, yeah, since this starts at 1, maybe I should just say vec. Maybe I should have all of these things have an extra row. Self grid push vec new, right? And then self row push 0. And that way we don't do this thing here, because maybe this is throwing me off. No, it's the same one. What else could be, oops. What else could be wrong? We add up all the power levels. If it's the biggest one so far, we save the X and Y coordinate of the upper left. And we save that. It still is the upper left, right? The top left coordinate. Yeah. Let's do these and see how close we are, right? For grid serial 18, it should be a 16 by 16. Oh, wait. What am I supposed to be putting in there? Maybe I'm putting the wrong thing in there. It's the size of the square, not the size of the power, not the power. Oh. So this could have been right all along. What size is that? 8. Oh, I'm such a dummy. All right. So we actually want to see, we don't care about, okay. Window size equals 0. Window size equals size. And it should be size. And it should be a window size. All right. So now let's try running this. Yeah. All right. And now the next thing to do is to actually speed this up. But I got it working the slow way, the brute force way. Git status, git commit -am 2018 day 11 part 2 the brute force way. And then what I need to do is I get rid of this print line. And then if we see if we can figure out how to do this, basically go through all the y coordinates, subtract the one before it, which I conveniently stuck as zeros in for the first row. Oh, no, I didn't. Vec 064. Oh, I64. 0 I64 semicolon what? 301. Yeah. Okay, so now there's zeros up above it. So what I can do is subtract. Actually, I didn't need the above ones, right? I just needed to subtract. Oh, we need to have an initial size at the beginning of the row and then work on that, right? So how do we do this? We grab these lines and move them up here. Like this. This sets up the initial power level, which we're going to have to start over here. Right? And then we're going to compare it. So we still have to do this business. And then for each y, no, for each x, we're going to flip this around, right? We're going to say for x, for y here and for x here. And we're going to walk along. And we're going to subtract the one before it, which is y minus 1. And we're going to add the one after it, which is, x minus 1. And then we have to do this thing again. Actually, we could just assign these, right? Here. No? Okay. So how are we going to do this? We're at a row. Oh. All right. I know I can do this. So we have to, for each one in dy, we have to subtract x minus 1 and add x plus size, right? There, like that. Okay, so now this is our initial power level. We're going to save it if it's the maximum, right? And then now we're going to walk our way through all of the x coordinates. How are we going to do that? We have to work for dy in 0 dot dot size. We're going to take the one before us in our x coordinate, subtract it from our power level. Self grid dy plus y as u size. X minus 1 as u size. And then we're going to add the one after it. We're going to do self grid dy plus y as u size. I got my brain fried. And then instead of x minus 1, it's going to be x plus size as u size. This might be an off by 1 thing here. We might have to subtract 1. But it's basically, if x is 1 and size is 3, yeah, we're moving to the next one. And then now we can recheck the power level. Right, after we've done that. Right, and then this might be faster because we only have a single loop here instead of a double loop. We have dx dy here. This is just a y. Let's see. I don't even know if it's going to work. I'm going to actually put that print line back in so we can watch things go. There's the size. What was it? Nope. I'm just checking my buffer here. It's somewhere in one of these buffers. There it is. Okay. Oh, it blew up. Len is 301, but the index is 301. That's a line 43. Yeah, I probably have to subtract one here. Does that make sense? Oh. Oh. Maybe this shouldn't go to +1 then, because we're moving to the next level, to the next line. Yikes. Nothing's working. All of our X and Y coordinates are broken. Oh, because I found X here. But that shouldn't matter. Right? It should still save the right power level. Let's print out the power level, because maybe the power level, it's obviously the power level calculation is wrong, right? Max PL. Or maybe that was the problem. It's running faster. Did it find the right answer? It did. 232, 289. Okay. So I think that's better, right? That's running faster. We can get rid of all these prints now, because I think it's going to come out right away. But now part 1 is wrong. Oh, and this was that? Yeah, 232, 289, 8. But this is wrong. This should be 3354. So I broke part 1. How would part 2 work? Let me see what it says for size 3 here. Yeah. That's wrong, huh? How does it work for part 2 but not for part 1? I assume these are just test power levels. If I say cargo test, that should still all work. Yeah, all the tests pass. What's that's so annoying. Why would it work for part 2? And this doesn't work for part 1. Do I have to do something different here in part 1? It just says highest coordinate for size 3, and it's coming out with (166, 142). And that's saying it's 39 there. I wish I'd remembered what. We can check grid serial number 42, which should be 2131 with a total power of 30. We can check that. Where do I store the serial? Here. 42. $53.21. That's wrong. It's supposed to be $21.61. The total power of 30. Let's do that. That's interesting. So I'm running it in yeah. Why? Why? Okay, this is going to bug me now. How it works for part 1 but not for part 2 is beyond me. Let me look at some of the other ones here for part 2. Let's see, serial 18. 92, 69, 16. Perfect. And the other one was serial 42, which we already looked at, but 232, 251, 12. Ah, so there's still a bug. Am I not going far enough? Oops. Am I not going far enough? The size is 1. We're going to go to, oh, because I did an equals here. I wonder, no, but then it wouldn't be getting the coordinate right. So it could be just luck that we got our value correct. So we want to get this to work for all, not just by luck. So this is 289, 8. So it's very close to the edge, but it's not at the edge. This is definitely not on the edge, right? 232 plus 12, 251 plus 12, they're both under the edge. Same with this. So it's definitely something in the middle. So maybe this part is not working. In order to move forward, we need to subtract the one that we're currently starting on. Yeah. And that'll give us the next one in the sequence. I think that's the way it should work. Let's find out. $231, $251, $12. That's correct. All right, let's do the 18. Here. And this should be 90, 269, 16. 89, 269, 16. This, oh no, this one's off by 1 also. Oh, okay. So maybe these are all off by 1. The Y value is not correct. It's off by 1. The X value is correct. The Y value is not correct. So let's try my serial number now, or my puzzle input, and see if it's also off by 1. So I'm predicting it'll be 231, 289, 8. Right? Yeah. Okay. So now the question becomes, why is the Y coordinate off by 1? This is at Y. This saves the Y. Oh, that's the X coordinate. It's the X coordinate that's off by 1, because we start here at 1 and we move to the next coordinate here. Right. So we actually do need to add 1, because we're shifting to the next grid here. The other option would be to go 0 to 300 minus size. Right. This should fix it, because I'm sticking the 1 in, but I think it makes rational sense that at line 1 we're actually shifting forward to 2. Right? At x equals 1, these two things shift us forward to x equals 2, and then so now we're checking the power level for x equals 2 here. So that's what we've got to put in our x. Right? Because we've already gotten x equals 0 here, x equals 1 here. So this is the next one. In order to avoid this, maybe what we can do is this. And then we'd have to subtract 1 here. And do that here. That should still give us the right answer. Yeah. Which makes more sense? I think this makes more sense because we started x at 1 here, and so we should start x2 here. And then this just gets subtracted. Okay, let's go with this. This is this, and this is that. And Clippy, let's see how long it takes to run. Oh, I should get rid of the output, right? That's not part of the... Yeah. So we'll let that run in debug mode while we do this. Okay. So I think we're good. Git diff. Yep. So this uses the sliding window mechanism to speed things up. Git commit -am implement sliding window for speed. I don't know if there's a even faster way. It probably is. Yeah, it took 30 seconds in debug mode. And in non-debug mode, how long does it take? In release mode. All right, git push. I think that's going to wrap things up. Thank you, everyone, for hanging out with me. Yeah, it took 1.4 seconds. So there must be a lot of, for debug mode, there must be a lot of bounds checking.